Hey everyone, Miss B here, and this is Unit 1, Lesson 10, Cumulative Practice Problems for Illustrative Math Geometry. So let's take a look at our first question here. This one is giving us four different sets of triangles. They have each been transformed by a different transformation, and we want to know which one is not a rigid transformation. So what a rigid transformation does is preserve the size and shape. So we are looking for a set of triangles here that have not preserved their size and shape. And for us, that is going to be this group right here. That is going to be D, because that triangle has gotten bigger from the blue to the green version. So that one is not a rigid transformation. Question 2, we're going to look at the definition of congruence. So we have a couple different things here, and some of these are more um, colloquial or just general definitions of congruence, but we're looking for the mathematical one. So if two figures have the same shape, then they are congruent. Congruent figures do have the same shape, but they have a lot more than that. If they have the same area, they are congruent. They also have same area. If there's a sequence of transformations taking one figure to another, then they are congruent. That is also true. But the correct answer here is D, because there has to be a sequence of rotations, reflections, and translations that take one figure to the other in order to make something congruent. These are all rigid transformations, and choice C doesn't actually give us rigid transformations. It kind of says just transformation in general. And it could have been a transformation like in question D or option D from the one above. That's a transformation, but it's not a rigid one. Rigid transformations preserve that size and shape, and that's why they're important, because they preserve congruence. All right, if we look at question 3, we now have a series of rigid transformations that takes A to A prime, B to B prime, and C to C prime. The same sequence takes D to D prime, but we're going to draw and label D prime and show how we found D prime. So if it takes A to A prime, we can know that we're moving some distance here, and it could just be a translation. If it takes B to B prime, that's a much bigger distance, and we could be moving that bigger distance, or some combination here. So, because it does tell us that there's a sequence, and we have C and C prime. So D is actually going to be, or D prime is going to be in the same, whoops, sorry about that. There's going to be a sequence that takes D to D prime, and if D has this relationship here between B and C, we know that D prime is also going to have that same position or relative position, D prime. So what I'm going to write down here is where I'm going to say um, I found D prime by placing it on the segment, which is B prime C prime, because it would maintain the relative position. So we're going to say I found it by placing on the segment B prime C prime, because it will keep the same relative position as D has to B and C. Hopefully that makes sense. Basically, if point D is halfway in between B and C, D prime should also be around halfway in between B prime and C prime. So some explanation that works for that. This is just my example. There are going to be a bunch of different ways of saying this that will be accurate and correct. So let's move on to our next question. For question 4, we are actually skipping question 4 on this assignment. So it says skip. And we're going to move to question 5. So question 5 says, to construct a line passing through point C, all right, you see point C right here, that is parallel to the line AB, Han constructed the perpendicular bisector of AB. So AB is right here. Han is constructing this perpendicular bisector and then drew line CD. Is CD guaranteed to be parallel to AB? Well, the short answer to this is no. It is not a guarantee that this is going to be the same distance. So we will say no. We really need a second set of perpendiculars here. So it looks parallel, but it's not guaranteed. So we can say no, the line looks parallel, but it is not guaranteed. So what we do want to do is explain kind of how you would need to do that. So we would need this line perpendicular to AB, and then we would have to construct another line perpendicular to this new line. So we have to create a line perpendicular again at D, or we'll say we'll have to create a line perpendicular again that passes through CD. C and D. So essentially what we're actually going to need here is another circle drawn around D. I'm very bad at drawing accurate circles here. We would need another circle drawn here around D. I'll just sketch it using my laser pointer. We would need another circle here drawn around C even. Well, we can do the perpendicular bisector here, but we just need a line perpendicular to this now perpendicular line. Because if we have two lines that are perpendicular to the same line, that's going to make them parallel and guarantee that for us. So we have one line and one line that's perpendicular to it. We have to make one that is again perpendicular in order to make it parallel. And it just says that Han drew line CD. He did not do anything to make it perpendicular. Okay, let's look at question 6. This diagram is a straight edge and compass construction of a line perpendicular to line AB passing through point C. So it's line AB, and then they gave us a point C So we made a perpendicular bisector passing through it. That's what that tells us. We want to select all the statements that must be true. And if they told us it's a straight edge and compass construction, that just means we know it's been constructed properly. So all of these circles are actual circles and all of these lines are straight lines. So what do we know has to be true? Let's look at AD equals BD. Well, nothing here tells me that D has to be halfway in between these. They might look like they're the same distance, but actually from D to A, that's the radius here of circle D, and B is inside of circle D, so it actually can't be true. So it's not going to be the first option. Now we have EC equals AD. EC is right here, and AD is this piece right here. Those are also not guaranteed to be equal. They are going to be perpendicular to each other, but they're not going to be equal to each other. They would have to be radii of congruent circles at this point for us to consider them to be equal, and they are not. AC equal to DC, so AC equal to DC, yes, because if C is a circle, A and D are both on the outside of it, so that would make AC and DC both radii of congruent circles. So yes to this one. Let's look at our next option. That is EA equals ED. EA equal to ED. This is again going to be true because these are radii of congruent circles, AE and DE. We know the circles are congruent because they pass through each other's centers. And so they have that shared radius. And so EA is a circle, is a radius of circle A, and ED is a radius of circle D. So these, yes, are going to be congruent. ED equal to DB. So I always like to trace my lines here. ED is here, and then DB extends here. Also not true, because ED is a radius of circle D, and B does not qualify as a radius because it's inside. We actually have to go past it in order to make a radius of circle D, so also not true. Oops. Accidentally hit my select tool there. Okay, so our last one is CB equal to AD. And this one again is going to be incorrect. CD is our short line here, and AB is much longer. They're not going to be congruent to each other. Oh, I'm sorry. This is CB. That was my bad. CB being congruent to AD. These ones look like they could be, but again, AD is actually a radius here of the circle, and from C to B, we do not know that this is a radius of this circle because it doesn't hit the center of circle D. It kind of passes through it. We would need it to start here and then extend to one of the sides. So also not true. And that should be it for homework number 10. So yeah, you can always ask questions in class, but thank you for sticking with me through this lesson. That is Unit 1, Lesson 10 of Illustrative Math Geometry.